Welcome everyone to another episode of CNC Basecamp. Glad you're here with us. Hey, today we're going to do something fun. We are cutting brass. Brass is a great metal to work with, and if you've never done metal cutting on your CNC, it might be a good time to start. Brass has a lot of different functions that you can use it for, but I think making tools is one of its best. Who can resist shiny brass tools? I certainly can't. So we're going to make two tools today. One is this small, handy square. The next is this large-scale compass. And this size of compass is fantastic in a shop because there's just so many uses for it that a small standard drafting compass can't even touch. So two great projects, we're going to show you how to do them. This episode is sponsored by Inventables. Design it, build it, sell it. Learn more at inventables.com. Well, our first project today is going to be this square. And there are really two parts to it. One is creating these wooden scales. The scales have V carving because I decided to glam it up a little bit with our logo. And the other part is, of course, the brass blade. Now the scales are held onto the brass blade by 4 cutlery rivets. And these are an easy rivet to use. They look great. So the first thing I'm going to do is work with the scales. And I'm doing that first because my surface, my spoil board is nice and clean. And when I go to cut the brass, I have to squirt a little oil about and things are going to get messy. So first thing I'm going to do is get the machine ready to go and we are going to cut some scales. What you see here is the preparation for the tool paths for the little scales that we're going to be cutting on the CNC machine for our CNC Basecamp squares. Let me click on tool paths and you can see there are 4 different tool paths that are going to go into the creation of these scales. Let's take a look at the first one, which is V-Carve 1. What I'm using is a 30-degree V-carving bit. I have a depth of cut of 0.03 inches for how deep it's going to go. And then I'm choosing a simple offset cutting pattern within these small little letters. So it's pretty simple. For the bit itself, I've selected a feed rate of 100 inches per minute, a plunge rate of 30 inches per minute, and an RPM of approximately 1600. And that's a pretty good setup for a small bit like that. It can go pretty fast. So let's close out of the V-carve and let's go to our next cut, which is the pocket cut. This pocket cut is going to be for cutting the holes that the rivets are going to pass through. Now I'm using a 1/8 inch end mill. That end mill has been preset at a pass depth of about 0.1 inches, a feed rate of 60 inches per minute, and a plunge rate of 10. Our next cut that we're going to do is going to be another pocket cut. This cut will actually cut the recess that the head of the rivet will set into. And it's the same parameters as before. Our final cut is going to be the profile cut, which will separate the part from the motherboard. I'm using a 1/8 inch mill. It has the same settings as we used for drilling the holes for the rivets. One interesting thing though is that I've added tabs, and that's what each of these yellow squares represent. That is a tab which will help hold that part in place and prevent damage as the bit cuts all the way through the wood. So let's go ahead and close out of that, and then I would like to run a preview so that you can see how all these different cuts come together. A little fast there, but you can see the preview will show us exactly what the machine is going to do. Previewing is a great way to avoid mistakes because what you see on the screen there is what's going to happen with your CNC machine. So make your mistakes on your screen and not with your parts. A couple details about the scales. Our V-carving was done using a 30-degree bit. Now that's a very sharp pointed bit, but what I wanted was steep sidewalls to create nice clean, vivid lettering at such a small scale. This is a solid carbide bit, and it does have a very small flat on the very tip. The perimeter was cut out using a 1/8 inch 2-flute bit. I like 1/8 inch bits because they don't eat too much material and they can get into tight places. One thing I like to do when V-carving is to use a brush to clean out some of the fuzzies that the bit doesn't remove. The brush that I like to use is this palm fiber brush. It gets down in and it really cleans things up nicely. The wood that I'm using is cherry. The red to pink tones that the cherry brings, I think, are really going to complement the yellow brass. It will create a very lovely looking square. Well, it's time to start cutting some brass. We need to cut the blades for our squares. So let's talk a little bit about what brass is. Brass is an alloy of copper and zinc. Now, there are a couple different kinds of brass available. One alloy is marine brass, and that's alloy 460, and it's very corrosion resistant. Another is alloy 260, formable brass. And of course it works very easily, both cold and hot, great for stamping. The brass we're using today is alloy 360, and that's known as free cutting brass or machinable brass. It has a little bit of lead added to the mixture, and that lead gives the brass a little bit of what's called lubricity, so it doesn't gall your bits up as bad, and it also keeps the bits sharper longer, not quite as hard on them. In order to cut the brass, we do need the right bit. Now with brass, we can use either a single flute bit or a 2-flute bit. I'm going to choose a 2-flute bit for this operation. 2 flutes will give me a little finer cut, and 2 flutes results in a slightly more stable bit. A couple things we want in a router bit. One is we want the shortest overall cutting length possible because a shorter bit will be more rigid and will not flex as much. I'm also choosing a bit that has a ceramic coating. Ceramic coatings are slipperier, so less chance of material sticking to the bit. They will dissipate heat, and that means a sharper bit and more bit life. Once we go ahead and have things set up, I need to think about what the feed rate is going to be. The feed rate that I've chosen for a hobby machine for brass is going to be 35 inches per minute. The depth of cut, 0.03, so a little less than 32nd. When cutting non-ferrous metals, we need to take a fairly light cut, but we're cutting small parts, and you'll be surprised how quickly you'll accomplish what you want. Once the bit is in operation, it's important that we add a little bit of lubrication to help the bit along. What I'm going to use is some aerosol cutting oil. It's easy to use, and it's the right oil for the job. Along with lubricating the bit, we also need to be very careful that we don't have any chip buildup within the kerf. So 2 ways we can handle that. One is vacuuming it out, and the second is to use a little bit of compressed air. So I may step in and use some compressed air. When we use compressed air, it's very important that we be careful. I'm going to set the regulator of my compressor at 20 pounds per square inch, so a very low pressure, and I'll be sure to wear safety glasses. When we cut the scales, I used a wood tab to hold the parts within the motherboard. I'm going to do something a little bit different. Now, tabs are fantastic, but they can also be a bit of a hassle in order to clean things up later on. So in this instance, what I'm going to do is have the machine cut the holes for the rivets that are going to bind the scales to the blade. Once those rivet holes are in place, I'll go ahead and stop things and take a screw gun, and I'm going to go ahead and put screws through each of those holes. Those screws are going to hold the square blades in place. Therefore, I don't need tabs, and the machine can cut cleanly all the way around the perimeter. And that'll just make things easier for me when it's time to clean the blades up. Well, it's time to finish up our little squares. So I've got some cutlery rivets, our parts, and I've got a metal plate here to help with the riveting. First step, make sure I've got the scales oriented correctly. I'm going to go ahead and place the female portion of the rivet each of these holes. It's a good idea to make sure all the rivets are in place before you start, because things can shift a little bit. So holding it firmly on my plate, I'm going to go ahead and start the rivet. They're easy to use, but it's always best when dealing with rivets, once you get them started, and that's the tricky part because they're so darn small. You don't want to be tentative about it. Drive the thing home. And you want to make sure when you're hammering, you want to pick the hammer up and drop it vertically. Don't use a lot of wrist action. Go from the shoulder. Because it's kind of frustrating to get to this point in the project and find yourself drilling out rivets and trying again. There we go. Great little square. So I put CNC Basecamp on it, but you can put whatever you like. If you belong to a woodworking club or have someone you need to give a gift to, there you go. It's a great project, great gift. Well, here are the brass blades that we cut for our squares. They're the right shape, but as you can see, they're a little rough on the outside. A little grimy looking, got some oxidation. What we want to go is from here to here, something shiny, something that will make a pretty tool. So how do we do that? Well, we've got a couple of different choices depending on what finish, what look you want. The first one I want to talk about is to use abrasives. What you see here is a fence, a flat board, and a piece of PSA sandpaper. You can start at any grit. What we want to make sure is that the striations that the grit leaves are all uniform and in line. And that will make for professional looking work. And that's why we have the fence. Back and forth, holding things in line, and little by little we'll start to remove some of the oxidized area and reveal nice clean brass. As you can see here, I've got a little ways to go because I'm hitting the outside first. So there may be a slight bow to this brass. I can flatten that out. I'm going to keep on doing it just a little bit more here. Now you can stop at any point with a grit, or you can continue down to a very fine grit. I have 220 paper on this board now. I could keep going to 1200 and it would start to approach a nice polish. So that's a nice, easy way, low tech, to create a nice finish, and it really doesn't take much in the way of materials or supplies. If you'd like to go for a nice polished look, well then we need to talk about another method, and that is using buffing wheels. There are three kinds of buffing wheels: soft, medium density, and a hard density. The soft wheels have the advantage that they'll reach into complex textures. A hard wheel on the other end of the spectrum can really cut into tight areas and leave a very clean line. So it really depends what you need to do. I like to use a medium density. It's a good all-around wheel. And so that's what I've been using for our blade squares. Buffing wheels, of course, require a compound. This is red Tripoli, which is a good all-around compound for polishing brass. Another good tool for dealing with metalwork are these 3M pads, and they come in different abrasive qualities. There's a fine, medium, and an ultra fine. And these are really handy because you can do handwork with them. And so if you have some scratches or a blemish that you'd really like to work out before you use the buffing wheels, it's a great way to go. Low tech, but it provides nice, good results. And of course, like the sandpaper, we want to always make sure that our striations are even and consistent and make your work look a lot better. The last way, that's the easiest way, and I really like it because it just yields great results, is to use a vibratory tumbler. Now, a vibratory tumbler is a common machine for finishing metal parts, be they steel, brass, or aluminum. This particular machine, as I said, is a vibratory tumbler. There are models which are actually rotary tumblers. So think of those rock polishing kits that kids like to use. The same principle works the same. Now, when we load our parts into a vibratory tumbler, we need to choose what kind of media goes in with it. And there are three kinds of media. This is ceramic, and it comes in a variety of different shapes. The best shape is the one that doesn't get lodged into tiny areas of your work. You want something that'll reach into everything, but not get lodged. And it's the most abrasive of the three. What you see here is plastic. So plastic will provide a pretty good polish to brass or to aluminum, and it's a little easier on the material. Our final media is a treated walnut shell, and that provides the highest gloss for any metal that you're polishing. Now, the length of time that it takes can be anywhere from 2 hours to 12 hours for each one of these. It really depends on your product and on your material. When we're using the ceramic or the plastic, it's necessary to add a little bit of water and a little bit of a polishing compound. This is more or less dish soap, but it has some good properties which keep the surface from oxidizing. So you add just enough to lubricate everything, but you don't want it to wash in the liquid. So a vibratory tumbler, it's a great thing if you get into metalwork. You'll find it really creates great parts for you, save you a lot of time. Well, I'm all set to begin our next project, and that is a compass. Here's the cutting file for the two legs and the retainer. You can see the outlines in the picture and the material from which they're going to be cut. And here are the two different cuts we're going to be making. This is the pocket cut, and the pocket cut is dealing with the holes for the rivets. And here we have the profile cut, which is going to handle the outline of each of the legs and the retainer. You can also see here these little yellow squares with T, and that is where I'm adding a tab so that the part will not separate from the mother material. So what I'm using, of course, is an 1/8" end mill. It's made specifically for metal. And whereas we would set a depth of cut at, say, 1/10 of an inch if we were cutting wood, in this case I'm setting it for approximately 0.03 inches, so a little less than a 32nd. And that's a good amount for a small non-ferrous bit. We don't want to go much deeper than that. And it doesn't sound like much, but with just a couple of passes, we'll get through this piece and we'll get good results. I'm also going to slow the feed rate down. If I were cutting wood with an 1/8" bit, I might go through the wood at, say, 60 to 70 inches per minute. I've slowed that feed rate down to 45. And also, I've slowed the plunge rate down. The plunge rate is 20. The two legs and the retainer are made out of 3/16 inch brass. The wings and the washer are made out of 1/8 inch brass. The setup for the tool paths is essentially the same. I'm using an 1/8 inch end mill. The feed and the depth of cut are the same. The mill is going to make the holes first, and then we'll move on to cutting the profiles for each of the different parts. So the main difference then between cutting brass and cutting wood is the specialized bit, the light cut, and the reduced speed. Well, we have all our parts together. So I've got both legs of our compass, a retainer, which will hold the wing in place. I've got the wing itself, and I've got this washer, which goes between the two legs, and accommodates the thickness of the wing. It's a good idea if we go ahead and polish our parts up now. Now we can polish them later after the compass is fully assembled, but when everything's free like this and flat, it's a good idea to go ahead and make sure we've taken out any scratches and bring things up to a pretty good polish. This makes life easier. On this leg, we're going to have two chores that we need to do. One is I need to tap this hole to accommodate a thumb screw so that we can lock the wing of the compass. I'll also need to add a steel point on the end of this leg. You can see I've already done that on this finished one. Now this steel point is pretty easy to make. Like most shops, you probably have a few dull drill bits laying around. So this is a dull drill bit, and I've taken it to the grinder and created a point on one end of it. I'm going to put this in the vise, and I'm going to knock off the twist drill portion of it, leaving me with a nice hardened steel pin. I'll drill a mating hole in the end of this leg and insert the pin in with a drop of CA glue, and that'll hold it in place. The other leg needs to have the barrel which will hold the pencil put in place, as you can see here. The barrel for the pencil is a bronze bushing. Now it's solid bronze, not centered bronze like many bushings, so make sure you get solid. The bushing has a hole drilled crosswise, and it is tapped to accept a 1024 threaded knob, and that's going to hold our pencil in place. Once I have the bushing prepared, it's going to be soldered onto the leg. With that, our preparation is done and we can begin to assemble. I'm going to be using two sizes of cutlery rivets, the same type of rivet that we used on our small squares. I'm going to rivet on the retainer. I'm going to rivet the wing onto the leg, and then I'll rivet the two legs together. Well, the next step in preparing parts before final assembly of our compass is going to be to solder this bushing, which is going to hold the pencil, to this leg. Now, one of the keys of a good solder joint is we have to have the parts fit correctly to begin with. So I have a round cylinder, and what I need to do is to create a matching shape in this leg. Now to do that, I'm going to use two files. I'm going to start off with just a triangular file, and I'm going to score a line right down the center of the flat on this leg. Now that line acts as a guide for what I'm going to use next, which is a round file. And there we go. So I've got a bit of a trough in this leg, and that will accommodate our bushing. So one thing we want to do to try and get a good solder joint is I'm going to pre-tin both surfaces. In other words, I'm going to heat this up and add some solder to the trough, just a light coating, and I'll do the same on this barrel. Then I'll set the barrel into the trough and heat both up together, and they'll fuse. And that way I know that I've got full solder along the whole length of the joint. I'm going to add a little bit of fluxing agent. And now it's time for some solder. This is just a standard acid core 4060. There we go. I'm going to set this aside and use my vise to hold our bushing. I want to make sure I clean off the surface a little bit because I've been handling it. And I don't want to leave oils on there. I'm going to add a little bit of flux. Now it's time for solder. And it looks like it's in the right spot, so now it's time to apply a little heat. I think that should have it. Now, of course, with all things hot, patience is a good idea. So I'm going to let that cool off, and then I'll get things cleaned up and we're ready to assemble. Well, it's time to rivet all our parts together and complete the compass. So I'm going to start by riveting the retainer onto the leg that has the pin. So you can, here's the retainer on our finished compass. So I'll begin by inserting 1/2 of the rivet through the parts. As before, we want a nice vertical motion and sink those rivets in with some authority. Next thing we're going to do is rivet the wing onto our other leg. And at this point, you do need to kind of start paying attention to which side you're putting things on. The wing can be riveted on fairly firmly because it really doesn't need to move. Now that we have the wing on, we can join our two parts. So now I'm going to add the washer, which separates the two legs. And I'm going to go ahead and get another rivet. And at this point, we want to make sure that our two legs can move. I don't want them loose, but I don't want them super tight either. I think that feels pretty good. Well, now I'm going to add the thumb screw in this leg, which allows us to set our diameter. I'm going to add a pencil and a thumb screw in the barrel. And there we go. That is our completed compass. And that finishes our two projects using brass and our CNC machine. This episode is sponsored by Inventables. Design it, build it, sell it. Learn more at inventables.com.